Linear equations are useful, powerful, effective mathematical tools that we can use for many different real-world scenarios. So we're going to look at a couple of examples of how we can create linear equations given a scenario. So our first scenario is we have a town and its population in 1980 was 6,500 people, and we're going to say this population grew linearly until the population was 11,000 people in the year 2010. I want to find a formula for P, the town's population, in terms of T, the number of years since, let's start in 1970. The first thing we need to do is figure out what is our X and what is our Y. Here, time is our X. Usually if time is involved, it's on our horizontal X-axis, and the population P is on our vertical Y-axis. So if I were to make a graph of this, then time is on the horizontal axis and population's on the vertical Y-axis. The next thing we need to do is translate the numbers we've been given into the coordinates of points. Let's see. We know that the population of the town in 1980 was 6,500 people. So 6,500 is a Y value. We are doing T in number of years since 1970. 1980 is 10 years after 1970. So our first point has coordinates X equals 10. Because 1980 is 10 years after 1970, Y equals 6,500. That was the population in the year when T equals 10. And then for our other point, that was the year 2010. That is 40 years after 1970. 2010 minus 1970 is 40. So there's our X coordinate, X equals 40. And there, the Y coordinate is 11,000. All right, cool. So what do we do next? Well, the next thing we need to do is we need to find the slope of the line m. The slope m is the rise over the run, which is the change in y divided by the change in x. So the formula for m is the y2 coordinate minus a y1 coordinate divided by x2 over x2 minus x1. So our two y coordinates are 11,000 minus 6,500, so there's our numerator, and the denominator are the x-coordinates subtracted, 40 minus 10. 40 minus 10 gives me 30, 11,000 minus 6,500 gives me 4,500. 4,500 divided by 30 is 150, so there's our m, there's our slope. Now any line can be written in slope-intercept form as y equals mx plus b, so our line must be P, that's our y, equals 150, there's the slope, times t plus b. So we're halfway there. So what happens next? Well, in order to find the equation of any line, I need both the slope and the intercept. So we know our equation is going to look something like P equals 150t plus b. I got to find the b. We can use the coordinates of either point. Any point on the line can be used to solve for b. So let's take that first one, the 10 and the 6,500. I put in 6,500 for the p. I put in 10 for the t. And let's see, I need to multiply the 150 times 10, so that's 1,500. So there's my equation, 6,500 equals 1,500 plus b. I want to solve for b. I want to get b all by itself, so I subtract 1,500 from both sides. 6,500 minus 1,500 is 5,000, and there's our b, there's our intercept. So the equation of our line is 150 times t plus 5,000. There's the equation of our line. It's always a good idea to double check our work. I think I've got it. I think the equation of the line that goes through our 2 points is P equals 150t plus 5,000. Let's see if it works. We can always double check our values by putting in those t values and seeing if we get the right p values. So for the first one is 10. So I do 150 times 10. So let's see, that's 1,500 plus the 5,000. 1,500 plus 5,000 is 6,500, and yep, that's what I should get. That's the correct y value. For the next one, I've got 40, so 150 times 40. My calculator says that's 6,000. We add the 6,000 to the 5,000, I should get 11,000. Yep, that's the number I should get. So the values of p are correct. So we've done it. Yay, we have the correct equation based on this data. Let's do another example. Let's do an example of ice cream cone sales because I like ice cream. An ice cream shop knows that if they set the price of a single cone at $2, they will sell an average of 40 cones per hour. And they know that for every 10 cents they increase the price, they will sell 2 cones fewer because they're charging more. And for every 10 cents they decrease the price, they will send 2 cones per hour more. I want to find a linear equation giving me the number of cones sold per hour based on the price we set. First, we've got to sort out what's x and y. X, in this case, is our price. That's the thing we control. This is the cause factor. The number of cones sold per hour, that's y, because that's the result. That's the effect. And that's the thing that results from all this. So this gives us the coordinates of a point on our line. When the price is $2, they sell 40 cones per hour. So our first point on the line has coordinates 2, 40. And we know that if I increase the price by 10 cents, so if x is 2.1, then I'll sell 2 fewer cones per hour, so that's 38. And I can continue going from, I can get as many points as I want. If I increase by another 10 cents to 2.2, I sell 36 cones per hour. If my price is $2.30, I sell 34 cones per hour, or I can go backwards. If I decrease my price by 10 cents, so the price is $1.90, 1.9, I'll sell 42 cones. So I've got a bunch of points on the line. I need any 2 of them, so let's choose these. Suppose my 2 points I'm going to work with are 2, 40 and 2.1, 38. Again, the slope m is y2 minus y1 over x2 minus x1. Here I've got 38 minus 40 over 2.1 minus 2. So my numerator is -2, my denominator is 0.1. My calculator says -2 divided by 0.1 is -20. And so if we write this in slope-intercept form, y equals mx plus b, we know what m is now. Y equals -20x plus b. Next, I got to figure out what the intercept, what the b is. I can take either one of those points and plug it in there into my y equals mx plus b. So y is 40. So 40 equals -20 times the corresponding x value is 2 plus b. -20 times 2 is -40. So I have 40 equals -40 plus b. I want to solve for b, so I add 40 to both sides to cancel out this -40 here, and I get 80 equals b, and that's my b value, so I can put that into my linear equation. Y equals -20x plus 80. I want to double check. Let's make sure we did our math right. And so we can plug some numbers in there. Y equals -20 times 2 plus 80. So we take our first x coordinate 2, we put it in there, we got -40 plus 80. Oh, 80 minus 40 leaves 40 left. And yep, there's the 40 that we should get. There's my y value. Or I can plug the other one in. -20 times 2.1, my calculator says that's -42. -42 plus 80, 80 minus 42 is 38, and yep, I've got it. The values of y are correct. We have the correct equation. Now we can even go beyond this and create a revenue function. The revenue that's the amount of money we make, the amount of money we take in, given x, the price we set per cone. So, for example, we know that if we set the price of $2 per cone, then we will sell y equals 40 cones per hour. Revenue is the dollars per cone times number of cones we sell. So that's 2 times 40. So that means we're going to make $80 an hour. We're selling 40 cones per hour and we get $2 each. So that's $80 per hour coming in. Now, using our linear equation, y equals -20x plus 80, we can create an equation for revenue in general based on any price x that we want to sell. So revenue is x, the price, times y, the number of cones we sell. So I can stick in my equation for y. So revenue is going to be x times -20x plus 80. To simplify that, I can distribute the x across. So this x meets that, and so we have -20x squared. This x meets the 80, so a plus 80x. So that's our revenue equation. Revenue equation is -20x squared plus 80x. So now we can say, well, how much money will I bring in if I set the price of a cone as being $2.50? Then we can calculate what that is. And we can say, let's see, that's -20 times 2.5 squared plus 80 times 2.5. And we find that, we bring in $75 per hour. That's interesting. So we'll bring in $80 per hour if we set a price of $2 per cone. And if we increase the price, we actually bring in less money because we sell fewer cones. So the revenue per hour goes down to $75 per hour. So maybe we don't want to do that. We haven't talked about costs or profits or anything, but this is how we can do it. Revenue can be calculated by multiplying the number of cones we sell, y, times the dollars per cone, x. All right, so in summary, to create a linear equation for a scenario, we first identify which number represents x and which numbers represent y. We got to sort that out. Then we can take those numbers and write those as the coordinates of points. We need at least 2 of them. We need to write down the xy coordinates of at least 2 points to figure out the equation of our line. Then we can, based on those points, we can find the slope m, the rise over the run, the change in y divided by the change in x, so that's y2 minus y1, all divided by x2 minus x1. And once we have that m as a specific number, we can use the coordinates of any point on the line to solve for b using our y equals mx plus b equation. And it's always then a good idea to double check and make sure the equation of the line is correct by putting in an x value, see if we get the right corresponding y value. And that's how we can come up with a linear equation for just about any scenario.